Perfect. I hope you can hear me well and see the screen. Thank you all for joining us today. I would like to begin by expressing my gratitude to Mohammed bin Rashid Space Center and the Emirati Society of GIS and Remote Sensing for inviting me to speak at this webinar. It's an honor to be here with all of you, sharing our passion for remote sensing and our environment. Today's webinar great as we dive into innovative strategies and solutions aimed at preserving and improving our natural world. As we explore these ideas together, I hope this webinar serves not only as a platform for sharing knowledge, but also as a catalyst for sparking new ideas and collaborations. In my presentation today, I will be sharing insights and updates on the latest advancements and developments in loss and damage and coral reef conservation. In this case study, it's focused on a small island developing states. We ran the study in the Maldives. Because basically, I mean, these states face the consequences of the climate change. It's my hope that these insights will inspire of you in your respective fields, leading to the development of future products and initiatives that contribute to a healthier, more sustainable planet. I think, together we can make a significant impact. Basically, what we want is to share ideas, and hopefully some of you can develop this further, and we can make big things. So this is the agenda that we will follow today. The first point will be just a brief introduction about 4AI and about my background. Then we are going to continue to start with the challenge, why this topic it requires attention. Then the consequences of these problems. The relationship between corals and temperature. Then we will continue explaining the solution that we developed, the data sources that we are going to use for this service. And after that, we are going to see the methodology or the workflow with, obviously we are going to explain each step. Just to see what we have done, what data we used, and what output we are going to get from this. After that, we will explain the sea surface temperature and coral atlas. These 2 points are the main input for this methodology. Then the alerts from this data, the analysis that we have produced, and the detailed coral reef alert map, which is the output, basically is the summary of all the input that we introduce into the methodology. Then we will see the outcomes, and at the end of the presentation, we will see the results that we found in this area in the Maldives, and the future work that we would like to develop. So basically, 4AI, for Earth Intelligence, is a pioneering company in the field of Earth observation and remote sensing. With decades of experience, 4AI stands at the forefront of using space-based intelligence to drive meaningful change and support environmental sustainability. 4AI's expertise spans across various domains, including Earth observation, remote sensing, digital expertise, geospatial mapping, mobile and software development, and the integration of artificial intelligence and machine learning. These capabilities enable us to provide cutting-edge solutions tailored to address the pressing environmental challenges of our time. Our mission is to contribute significantly to the improvement and protection of our environment. We achieve this by delivering critical insights and data to environmental agencies and engineering consultancies worldwide. Our work aids in monitoring and mitigating the impact of climate change, managing natural resources, and addressing waste and pollution issues. At 4EI, we believe that by harnessing the power of advanced technologies and collaborative efforts, we can pave the way for a more sustainable and resilient future. We look forward to working with you and exploring new opportunities to protect and preserve our planet. We have offices in the UK, Abu Dhabi, and Lahore, and basically we have projects in approximately 10 different countries. Just a brief introduction about me. My background is, well, I'm general manager at 4EI. My background is geography, and then I specialize in technologies of geographic and information, remote sensing, and GIS with a master's degree. And during the last 10 years working in this area, I've been involved in projects in environmental services like habitat mappings, blue carbon, and as well ecological corridors, security and defense. All of these using GIS data for models like chemical, biological models, border surveillance, oil and gas to detect oil spill monitoring using remote sensing, and as well topographic, creating digital elevation models, topographic maps, etc. Well, regarding the coral reef early warning system, basically, yes, to introduce that 500 million people depend on coral reef for food and income. Basically, coral reef is more than sustenance. They also supply protection. Basically, healthy reef protect land. These small island developing states are characterized by the small land areas, limit natural resources, vulnerability to natural disasters, and exposure to the impact of climate change and sea level rise. Basically, coral reefs play, in the case of Maldives and most of these islands, plays a vital role in the Maldives, and its importance can be understood through various aspects. First, biodiversity. They are rich ecosystems. The coral reefs of the Maldives are among the most diverse in the world, supporting a wide marine life, including over 1,000 species of fish, 400 species of mollusks, and other invertebrates. This biodiversity is crucial for maintaining the ecological balance for the ocean. Endemic species as well. Obviously, there are many species found in these areas are unique to this region. So that is why it's very important to preserve these habitats. Fisheries, obviously, it helps for the sustenance and livelihood. Coral reefs are the backbone of the Maldivian fishing industry, providing habitat for various fish species that are integral to the local diet and economy. Fisheries contribute significantly to food security and employment in the Maldives. As well, basically sustainable practices, obviously traditional fishing practices, which obviously have been followed over centuries, and obviously they are often sustainable. It's basically it's the most sustainable practice, and it's something that we should preserve. Tourism. Obviously, tourism is the largest industry in the Maldives, with coral reefs being the main attraction for tourists. Basically, all the activities around this, that is why it's very important for the economy as well. The hospitality industry as well. Basically, this supports a wide range of business all around this coral reef. As I said before, coastal protection, the coral reef acts as natural barriers, basically absorbing the energy of waves and reducing coastal erosion. This protective function is vital for the Maldives, where low-lying islands are particularly vulnerable to the impact of rising sea levels. As well, it acts as safeguarding habitat by protecting the shorelines. It helps. It acts like a nursery for fishes, so that for the fish. That's why the protection is very important. And as well, it's a carbon sink. It helps to regulate the climate. Coral reef play a role in carbon sequestration. The calcium carbonate structure formed by coral lock away carbon dioxide, helping to mitigate the effects of the climate change. As well, healthy coral reefs contribute to the overall health of the ocean, which is essential for maintaining global climate patterns and supporting marine life. And the last but not least, basically, it's a very important point in the tradition and culture of the Maldives. Coral reefs are deeply inside the cultural heritage of the Maldivian people. Basically, they are featured in local practices, community life. It's a symbol for them. And as well, basically, many the community activities involves coral reef resources, the cultural importance, maintaining healthy coral reef ecosystem for future generations. Well, regarding the challenge, as we all know, these small islands are facing the consequences of the climate change. Basically, there are many points, or some of them is, the rising sea levels. It's really a threat to land as global temperature rises. This lead to rising sea levels. So for low-lying nations like the Maldives, this poses an existential threat as increased flooding and erosion, and this can lead to loss of habitable land. As well, it affects the salinization of fresh water. Rising sea levels also cause the salinization of water aquifers, which is critical for drinking water and agriculture, obviously impacting food and water security. And as well, obviously, if this change, it will affect the economy of the island. So extreme weather events disrupt economic activities, especially tourism and fisheries. As well, for example, all this, the ocean acidification and coral bleaching, and as we said, the coastal erosion. So basically, these are the main challenges that these states are facing. So that's why it's very important the international support and collaboration. The scale of these challenges requires continued international support to ensure long-term sustainability for these small island developing states. Because obviously these states don't have the resources, basically don't have the need financial resources to implement climate adaptation and mitigation measures. That's why international financial assistance can help build resilient infrastructure. As well, they need help for disaster relief and recovery, and as well technological and knowledge transfer. So basically, we as the international community, we need to share innovative solutions. We need to provide capacity building. We need to work together to and as well the states to change the policies to help this. So basically, the lack of resources, as well, knowledge, financial resources, etc. That is why the international collaboration is needed. So, one sec. Yeah. So, so when we see this challenge, we developed a solution to provide instant and easy access to environmental information from remote sensing. because at the moment, obviously, we have the remote sensing data there, but sometimes working with that data is complicated. Basically, it's needed base a minimum level of knowledge about how to modify, how to work with the data, as well. Sometimes it requires a specific resources like a software, etc. So what we want to help with this is to translate the raw data from satellite directly to actions. So basically, we want to democratize the remote sensing data. We want that everyone can access to this data, but in variable, like an understandable data. Basically, not only seeing numbers or pictures. It's just to say, okay, this area requires action. This area requires protection. Basically, it's just to translate from numbers, from pictures to actions. So with this, this information will help to monitor the coral reef ecosystem, and as well to receive early warnings, because basically we are going to monitor every month the water quality that and the parameters that is going to affect the corals, with the idea to plan and make policies to mitigate the risk. So as we can see here in this schema, the first step will be monitoring. Then we are going to analyze all the data to understand the data. And then once we have identified the areas, we go to the planning stage, and then the last one is financing to obviously to create that action. So what we in this project, we as well the research review and the consultancy with the experts, we found Earth and the sea surface temperature. This obviously is known as coral bleaching. Basically, where obviously now with climate change, it raises the temperature of the water, and this affect and can increase the frequency of the coral bleaching events. So basically, understanding this relationship between coral and temperature, we can predict and mitigate the impact of this in the areas, and then to create a model to say, okay, the temperature is rising in this area, and then we can alert the authorities to make any actions on this. So, for example, we have these some example. Obviously, these are from previous projects that we developed as well. We work on the coral health analysis, and these are some example of fieldwork data. So basically, as we said, when the temperature, the sea surface temperature, goes to 30.5, in this case is in the Maldives. I have to say that we found that the corals are adapted to local areas. So basically what we found is this temperature is for the Maldives corals, but we found that in Abu Dhabi waters, in Arabian Gulf, the coral can resist higher temperatures. So basically the idea here is we have to adapt the model to specific waters, because every coral, every species is adapted to different temperatures. So in this case, we are talking about the Maldives. And then obviously when temperature is 30.5, the coral, well, the bleaching process starts. And then when it goes to 30.9 is when it requires an imminent action, because basically it's a severe bleaching. Basically is when the coral, if this temperature continues during the weeks and months is going to be critical. So what is coral bleaching? Basically, the bleaching process occurs when coral are stressed by changes in conditions such as temperature, light, or nutrients. The most common cause of coral bleaching is the increase of sea temperatures. Basically, when this temperature is high, the coral starts to expel the algae, or the living creatures in their tissues. So basically, without this algae, the corals lose their main source of food, and the coral is turning white. That is why it's called bleaching. Then, as I said, basically it's linked with the sea temperature. Obviously, we can see this with climate change, that the average sea surface temperature is higher in the last decades. And as well, the temperature stress, when the temperature is high during a few weeks or more than 2 months, it's causing a stress level in these habitats. And then obviously when more than 2 months the temperature is high, then the corals can start to die, because they need the algae for energy. So as I said, we developed the Coral Reef Health Early Warning System. Basically, using all this data, we monitor the areas every month. We correct all data, every data available in that month. We correct it, we process it, and we create a report, and we create a map at the end of every month to help authorities to make this done. So for this case, we focus on the north central province of Maldives, basically in this area that we can see in the screen. For this, what do we need? We need satellite imagery with thermal bands and coral reef maps. Basically, these 2 points. We only need 2 points, the temperature and the coral reef maps. Where can we find the data? Well, there are many satellite sensors where we can go and extract the data. For temperature, we have the Landsat series. We have 7 and 8. We have Sentinel-3, which is in terms of resolution and reiteration and frequency is very good. And we have the MODIS. We have used MODIS in other projects, and the spectral resolution is really good. And then on the right hand side, we have some other sensors like a geostationary satellite, and the NOAA, Aster, etc. For this project, we have used Sentinel-3. Then for Coral Reef Map, we use RM Coral Atlas. I will explain a bit more about this. At the moment, is the best base map for coral. Obviously, it's worldwide and it's free. And then for multispectral imagery, we use planet imagery in this case. As I said, the sea surface temperature, we use the ESA Copernicus Sentinel-3. With thermal infrared sensors, it is possible to measure the sea surface temperature, whereas the sensor registers the signal coming from the very top surface layer. The measured signal is calibrated to provide the bulk temperature of the water body at approximately 1 meter depth. Basically, this is very important to mention. It's sea surface temperature. Obviously, it's at the moment like a 1 meter depth. No, we cannot estimate the temperature beyond this value. So the temperature maps are useful for identifying the variation, the spatial variation and flow patterns of the water. and as we're identifying frontal systems. So in this case, we extract the sea surface temperature in Celsius, and then the coral reef areas. Obviously, we use RM Coral Atlas as a base map, but this is from 2022. But obviously, for this project, we wanted to have the most up-to-date map. So it's possible to extract coral reef from satellite imagery. This involves using image processing techniques to distinguish reef features from water, seafloor, and other habitats. So 4AI employs various remote sensing algorithms and spectral indices tailored to specific characteristics of coral reef, such as their unique colors and reflectance properties. These algorithms help differentiate coral reef from other underwater features based on their spectral signatures. Additionally, advanced image classification methods, including supervised and unsupervised classification, are used to classify pixels within the satellite imagery as a coral reef, other habitats, etc. These methods often require extensive training datasets to accurately identify and extract coral reef areas. So that's why we use planet imagery. We use other multispectral satellite image to update the coral map. So this is the methodology that we followed. We will explain later in the next slide every step. So basically, we start with the data collection. This is obviously this monitoring system involves collecting various types of data, including water parameters, water quality parameters, and as well the coral cover. Baseline assessment is just to establish a baseline to understand the natural state of the coral reef ecosystem. By documenting the initial condition of the reef, we can compare future data to what we have done in the past and identify potential stressors. Long-term monitoring, regular and consistent monitoring is necessary to track changes in the reef ecosystem over time. Long-term data collection allows us to identify trends, patterns, and anomalies. Data analysis and interpretation. Collected data are analyzed to understand the relationships between different variables and to interpret trends. Statistical analysis and modeling techniques can help identify these patterns and predict future actions. Then the early warning indicators, number 5, basically we need to identify specific indicators that signal potential threats to coral reefs. In this case, we selected the temperature of the water and as well the coral reef change. So when we see any difference, any change, we identify this as a threat, a potential risk. Then the rapid response and conservation actions. Obviously, when this system indicates or suggests a decline in reef health, a quick response plans can be activated. These plans may involve implementing marine protected areas, regulating fishing practices, improving sewage and waste management, and raising awareness among local communities and tourists. And then, obviously, the last point is very important as well for this is the community engagement. So involving local communities in monitoring efforts can enhance the effectiveness of every warning system. Local knowledge and observations are valuable, and as well, community engagement fosters a sense of ownership and responsibility, leading to better conservation outcomes. So basically, that's why, translating from satellite data to actions is important for everyone, because sometimes, the community doesn't know the knowledge about remote sensing. So basically, we want to put this data, this information open for everyone. So for the first step, we are going to explain the sea surface temperature. This is the first area. Obviously, for this we have used Sentinel-3. This data is free, is open source data. Basically, it's available for free from this link from the Copernicus website, Copernicus platform. The sea surface temperature is one of the most important climate variables. It's obtained calibrating with the calibration of 3 infrared channels. Basically, the uncertainty of this is 0.3 Kelvin. It is used in near real time. Basically, the product is available on the platform 3 hours after the correction of the image. And as well, this can be used for modeling, weather forecast modeling from detection, and to detect patterns in the water mass. Obviously, it offers 3 different sensors. The first one is what we have used, the sea and land surface temperature. Then obviously Sentinel-3 offers as well the ocean and land color instrument. It's very important as well to get some other water parameters, and then the Archimetry surface topography mission. But this is just a general information for our project. We focus on level 2 WST product, is the sea surface temperature. As I said, for this, we have used SNAP. I don't know if any of you have used SNAP. It's very, very useful to process data from ESA. It's as well open software, and it can ingest all data, like all Copernicus data, and as well Landsat. So basically, this is when we open the Sentinel-3, we have all these data, or these bands. We can see as well, excuse me, wind speed, surface temperature. This is what we selected, but as well aerosol. We have probably the crowd, the theoretical uncertainty, etc. So we have automated all these processes. Basically, we using Python, we can do this automatically, and in minutes, basically we download the data, we extract all the information, the sea surface temperature, and as well we run the crowd masking, we convert from Kelvin to Celsius, and we export it to TIFF. Basically, for this project, we have automated everything. Then in QGIS, obviously, sometimes we run a quality check, obviously, because for 1 month, we correct hundreds and hundreds of data. So basically, this is automatically, and then if we see one data is wrong, we check this. For example, in this case, we can see that crowd affect the temperature values, as we can see on the right-hand side. Basically, this it provides anomalies, it provides wrong values, but it's because there are some crowds here. So basically, we need to focus only on our area, and then to mask these areas, obviously, to avoid any anomalies. Then we need, for that, we have completed the temperature data. We need to focus now on the coral map. And this has been used as a base map and coral atlas. As I said, the objective of this project, the Arctic Coral Atlas project, is to map and monitor the world's coral reefs. It's a coverage, a global coverage. It uses high resolution imagery, and is totally free. It's available online from this website, and it's updated regularly. So basically, I think the last update, or at least when we developed this project, it was 2022. So it's basically it's really good to use as a base map. We can see here the classification. It extracts the coral algae. It doesn't identify the types of coral, but it tells us where the coral are located, which is really good for this project. Then what happened, because the coral atlas was, the last update was 2022. So we wanted to have an updated coral atlas, a coral map. So in this case, we use planet imagery. In this case, 2023 is when the project was done. It was last summer. Then we take as a base map the Iron Coral Atlas in 2022, and using the Coral Atlas as training data, we classify this running a random forest script, and we got the 4EI Coral Atlas, the 2023, basically combining the planet imagery, combining the coral Iron Coral Atlas, and then we got our own classification, our own coral map. Then, now, as a summary, we have sea surface temperature, the monthly average. We correct all the data for that month, and we calculate the average of the temperature. We have the updated coral reef for that month, and then we have the monthly coral change difference. So we can compare from previous month and this month, and we can see if any coral has been changed. Right, so basically then we want to create the alert. We have now this output, we have now all the information we need. So this is the monthly average sea surface temperature. We can see the areas, obviously, yeah, the maximum, in this case, this was for, if I'm not wrong, it was for August or September, and the maximum temperature in the water was 35 degrees, the minimum was 15. And then using the coral atlas, the coral map, we have identified which areas are in alert. As we have seen in the previous slide, temperatures reaching 30.5 degrees is obviously when obviously they are in risk. So selecting these values, we can identify that the areas in red are obviously suffering this stress, are suffering higher temperatures. As I said, yeah, 30.5 and 0.9. So selecting areas higher than 30.5, then we can then go one step further and detect breaching and severe breaching. So basically is just to go one step and then, okay, so the alert areas in red, which are, you know, having a very, I mean, what are the priorities here? So in the final map, we have the optimum temperature in green. So basically most of the area was okay, was good. The breaching process in yellow, basically it's like the temperature is around 30.5, and then the next level, severe breaching, is when obviously it reaches 30.9. So basically this is for this month. The idea is if this situation, these areas is repeating the same, you know, action, the same situation next month in September, and then in October, November, obviously is when something is obviously an action, an imminent action is required. The idea is to monitor this area, like, okay, this area, there are 2 months in a row with having this area, this alert. So the idea is to say, okay, please make any action on this to mitigate these areas. As we said, after this, once we have identified this area, we are going to create the detailed coral reef alert map. So only focusing on these specific areas. And for these specific areas, we use very high resolution image. So in this case, we use 50 centimeters planet image to obviously to create the map, the final map, the report for the authorities, saying, okay, these areas require actions. So the outcomes for what at the end of the month, this system will create the monthly report. So obviously, this will provide a comprehensive overview of the data observation, and as well the coral map and health assessment for this month. The map. So obviously, the idea is to provide as well an updated coral reef map. So the authorities can have, where the coral are located. Obviously, this is obviously there is a note here. It's automatic. This classification is automatic, and at this stage it has not been validated with in situ data. Obviously, this is to have an overview idea. And to have a general idea about the location of the coral, but it's not 100% accurate. It's just to have and to compare the modification. And then the coral reef breaching risk. As I said, we can select the areas and say, okay, the corals in these areas are in danger, are on risk. So please make any mitigation actions here. And just to finish the presentation, we are going to see the results that we got from this case study from the Maldives. So in general, using obviously for the coral alert map, we in this month it was August 2023 last year, we detect there are 5.4 square kilometers of coral in alert, and 20.8 of the condition was good. So in this case, the authority or the end user will receive this. There are 5 square kilometers that you need to pay attention. Then this is the workflow or the different steps, as we have seen in the previous slides. This monthly coral reef change detection using the reef, the coral map for that month. We compare it with the previous month, and we can detect if there is any change in corals. So in this case, we detected a decrease of 2 square kilometers, an increase of 0.8, and no change most of the area, 25.3. As I said, this is done automatically. So it's basically, according to previous projects, we have around 80-85% accuracy, but it's automatic from 3 meters resolution, spatial resolution, and as well it depends on the water quality, turbidity, waves, etc. So basically, we have some tolerances about increase or decrease. So 2.1 square kilometers could be okay. It doesn't mean that there is a real change, but obviously, if we see like a 90 or 50% of the area has been changed, in that case, yes, there is an alert, but this is within the tolerance. We can see here all these areas have been changed from the Allen Coral Atlas 2022 to the August 2023 using our very high resolution image. And the coral reef breaching map, we have detected that in August 2023, 20.8 square kilometers of the coral reef was in an optimum temperature, which is good. They are not on risk. Then 2.8 are on a breaching process. Basically, they have started with this process. And then obviously, if next month continues in this location, in this process, it requires action. And then 2.5 square kilometers of coral are in severe breaching. That requires immediate actions just to protect them. Basically, is the red area in the image here. Just as curiosity, this area is where urban areas or human activities are located. So next of the future work should be to relate, human activities with this breaching process. because and high temperatures, probably because the traffic transit, or as well the vessels traffic is higher in this area, so this affect the temperature. And then this is the specific areas. So obviously for the classification we use 3 meters imagery, and for specific areas we use 50 centimeters imagery. So we can see that the area that has changed is below 1 square kilometers for this area. So it's not very, it doesn't require imminent action. So future work, basically, this is we have done this. Everything is automatic now. We have the script, or we have created all the scripts, and this basically every month we collect all data, all available data, and we process it, and we create that report. What we want to develop here, and as well, basically, it's an open collaboration, because obviously this is a common a problem of everyone. The idea is to get everyone involved. Basically, is to create a platform where we can upload and ingest all this data, so the authorities and the community can log in and can see this data, can see the risk areas, can see the temperature of the water through this platform. So basically, if a town in the Maldives wants to see what is the condition of the coral, can access to that data and see, okay, we should do something in this area. We can, or probably they can limit the number of vessels in this area, or just to stop the fishing activities. So the idea is to share all this data to everyone, basically to democratize the data. As last, basically, I would like to thank all the team involved in this project. Basically, these are all the members of the team. As well, for this project we had the help of immediately students who helped us a lot processing the data and developing the scripts. So I would like to thank everyone there. And yeah, this is everything. I hope you enjoy this webinar. And as well, if you have any questions, feel free to ask. And as well, if not later, you have my contact details. Feel free to send me an email wherever you want, so we can discuss this and other questions.